Today we're going to talk about set builder notation. Before we start though, let's just say, for example, for some reason you had to list every single number between negative 1,000 and 1,000. That would be quite the task. You'd start from negative 1,000, then go to negative 999, negative 998, and you would be listing for quite some time. So for that reason, mathematicians came up with a way that you can list numbers really quickly, really briefly by describing them. And that description is called set builder notation. So I will write down something that is in set builder notation and we'll talk about what the various parts mean. So it looks like this. Let's say set A is described in this way. Now, what I'm writing down looks like a lot of stuff. It looks really hard, but it's not. It's not crazy. It's not hard. You've already learned what integers are, and you've already learned what this symbol right here means. So that means is a member or an element of. So basically, this portion of or set builder notation is telling us that x will be a member of the set of integers. It's describing for us that x values are whole numbers in this case. So x is a member of a set of integers, and then over here our notation tells us where the values are. It tells us that the values are between negative 1,000 and 1,000, and because we have or symbols here, the or equal to symbol here, that means it also includes negative 1,000 and it includes 1,000. Now, if we try to list those numbers, it would take quite a while, as we already spoke about. So instead of listing the numbers, I could just say that or set A can be described in this way: the whole numbers between negative 1,000 and 1,000, including those endpoints. Now, if instead, let's say we had another set, set B, but if instead those were, let's say, real numbers between, I could even make it a little bit smaller, the interval. So let's say it's between just negative 5 and 5. And for a little variety's sake, let's have one sign less than and the other sign less than or equal to. In this case, real numbers between negative 5 and 5. Well, as you may recall, real numbers are all numbers on the number line, which means that it would include 0, 0.1, 0.111, 0.111111, and there are infinitely many numbers between any two values. So in this case, because we are looking at real numbers, a set of real numbers, and that could be anything at all on the number line, this set is impossible to list. So in that case, this set, set B, is called an infinite set. It's impossible to list the values because real numbers is everything on the number line. In a similar manner, if I had another set, set C, and we were in the set of rational numbers, for a very similar reason, this set will also be infinite. You cannot list every single fraction or every single thing that can be expressed as a fraction between negative 5 and 5, and therefore this set is also infinite. But again, let's say D were the natural numbers natural numbers between, I'll use the same values so you can see the comparison here, between -5 and 5. We totally could list natural numbers between -5 and 5. Natural numbers, as you may recall, are positive whole numbers. So the first natural number between -5 and 5 would be 1. 2 would be the second, 3, 4, and does it include 5? Yes, it does, because we have the or equal to sign. That's a 5, not a 6, so let me rewrite that to make sure it's clear. So those are the natural numbers between -5 and 5, and it does, according to this, include 5, so I put it there. So we can list the natural numbers between -5 and 5. Now, if I asked for n of d, what I'm asking for is the number of numbers, or the number of elements in set D. In that case, we just count. There's 1, 2, 3, 4, 5. So the number of elements in set D is equal to 5. However, we can't answer that question for n of b. N of b cannot be answered because there are infinitely numbers between -5 and 5 that are real. So in this case, maybe you could just write the infinity sign, or say it's not possible to list them, so you don't give a number. So n of b is not possible. So n of any set is the number of elements in that set. So just to recap, the difference between an infinite set and a finite set. An infinite set, such as set B and set C, cannot be listed. You cannot give the number of elements in these sets because they are infinite. Whereas a finite set can be listed. The number of elements can be given, and they can be listed. And even though A was a humongous set, from -1,000 to 1,000, they were integers. So even though it would take a very, very long time to list it, it could still be listed. So set A is also finite.